Hello everyone and welcome back to the AWS Solution Architect Associate series. Today we continue with Domain 3, which is designing high performance architectures, and our focus is on one of the most impactful parts of the cloud design, which is high performing and elastic compute solutions. In this video we will explore the different compute services available on AWS such as EC2, AWS Batch, AWS Lambda, ECS and EKS, and also the Fargate. We will also dive into the distributed computing concepts, queuing and messaging patterns, auto-scaling strategies, and how to choose the right compute platform for your workloads. By the end of this session, you will clearly understand how to build the compute architectures that scale efficiently, perform reliably under the load, and remain cost effective. Let's get started. AWS provides a wide range of compute services, each designed for a specific type of workload. Amazon EC2 is the most flexible option, allowing you to choose the instance families, storage, and networking, and also the OS level configurations. AWS Batch is used for batch or the scheduled compute jobs that need queue based execution and resource optimization. For big data workloads, Amazon EMR provides the managed Hadoop and Spark clusters. Serverless compute like AWS Lambda is ideal for event-driven execution where you pay only for what you use. For containerized application, AWS offers ECS and EKS, and with AWS Fargate, you can run containers without managing the servers. Understanding these options and their use cases is essential for selecting the right compute model based on the performance, cost, and scalability, and also the operational overhead. Distributed computing is the foundation of modern cloud architecture. Instead of running all workloads in a single instance or in a single availability zone, AWS allows you to spread compute across the multiple zones, regions, or even the global edge network. Using edge services like CloudFront and Lambda at the edge helps you execute the logic closer to the users, reducing the latency. Event-driven architectures further enhance the performance by breaking the task into small async events that can run in parallel. By distributing compute tasks across multiple nodes, applications can scale more easily, recover from failures, and maintain the consistent performance even under heavy load. Decoupling workloads with queues and event buses is critical for designing the elastic compute solutions. Amazon SQS allows producers and consumers to operate independently by storing message temporarily, smoothing out the traffic spikes. Amazon SNS enables the pub/sub model where event can trigger multiple actions such as notifying the microservices or invoking the Lambda functions. These patterns improve scalability by preventing the bottlenecks and allowing compute workloads to scale independently without being tightly coupled to the upstream systems. AWS auto-scaling allows the applications to scale dynamically based on the usage patterns. EC2 auto-scaling groups automatically add or remove the instances based on metrics such as CPU utilization, memory, request count, or the custom CloudWatch alarms. AWS auto-scaling provides a single interface for scaling multiple resources, including DynamoDB tables, ECS services, EC2 instances, and Aurora. Advanced features like predictive scaling use machine learning to anticipate the future traffic. Choosing the right scaling policy ensures your application stays responsive during peak demands while saving costs during low load. Serverless computing removes the need for provision or manage servers and scales automatically. With AWS Lambda, code runs in response to events from S3, DynamoDB, API Gateway, EventBridge, or the messaging queues. Lambda functions are inherently stateless, making them highly scalable and fault tolerant. This model is ideal for micro APIs, automation tasks, data processing, and any workload with variable or the unpredictable traffic patterns. Because you only pay for execution time, serverless often provides the best cost performance ratio for event driven workloads. AWS provides two major container orchestration engines, Amazon ECS and Amazon EKS. ECS is AWS native orchestration service, whereas EKS is powered by Kubernetes for organizations adopting a cloud agnostic or Kubernetes first approach. AWS Fargate allows you to run containers without managing containers or servers and the clusters, improving the scalability and reducing the operational burden. Containers are ideal for long running services and microservices, CI/CD pipelines, and applications requiring consistent environment across development and production. EC2 families are tailored for different workloads. General purpose, which is used for everyday applications. Compute optimized is for CPU heavy workloads. Memory optimized is for in-memory databases and analytics. Storage optimized is for high throughput disk workloads. Accelerated computing is for GPU, ML, or the deep learning workloads. Selecting the right instance type ensures your workload meets performance goals without overspending. Always align instance type with compute characteristics such as CPU intensity, memory consumption, disk throughput, or the GPU requirements. Right sizing compute resources is essential for both performance and the cost efficiency. For EC2, choose the optimal CPU, memory, and the network performance to match your workload characteristics. For Lambda, the amount of memory also determines the CPU power. So allocating more memory means it can significantly improve the execution time. For containers, task level CPU and memory settings influence how workloads scale and how efficiently clusters utilize resources. Planning compute capacity ensures the workloads run smoothly while avoiding unnecessary cost. Elastic compute design depends heavily on decoupling components so they can scale independently. By breaking monolithic systems into microservices and leveraging SQS, SNS, Lambda, and EventBridge, you can ensure each component has its own scaling behavior. This prevents task traffic spikes in one part of the application from overloading other services. Independent scaling leads to more resilient architectures, improved fault isolations, and optimized performance for each workload type. When you combine serverless compute, smart container orchestration, distributed design patterns, messaging queues, and automated scaling, you create a compute architecture that is truly elastic. This solution ensures your applications can handle sudden load increases, process tasks efficiently, and remain resilient to failures. As a solution architect, your goal is to choose the right compute model and scaling strategy that matches the performance requirement, workload patterns, and operational preferences. So to summarize, in this video we explored how to design the high performing and elastic compute solutions using AWS services. We covered EC2, Lambda, batch, containers, orchestration platforms, distributed patterns, auto scaling, and how to choose the right compute options for different workloads. All of these concepts play a major role in optimizing performance, improving the elasticity, and designing scalable architectures. In the next video, we will continue domain 3 with the determining high performing database solutions, where we will dive into the caching strategies, replications, the engine selection, performance tuning, and how to choose the right database for each workload. If you are enjoying the series, don't forget to like, subscribe, and share. See you in the next session. Thank you.